Okay, good afternoon, everybody. Thank you for joining us today. My name is Maureen Gribble with UE Systems. Happy to have you guys with us today. Today we've got Rick Clonan from Eruditio, and he's going to be talking about asset criticality. He's got kind of a clever spin on how your plant sometimes can act like a teenager, and how if everything is critical, then, well, nothing is. So looking forward to that. Should be a really good topic, and kind of goes hand in hand with what we started last week with Sean Eisenhower's presentation, for those of you that were also here last week, where he was talking about planning. And so just kind of the whole idea here, just trying to give you guys topics that could hopefully come in handy as we're going through these uncertain times, and trying to give you guys some positive things that you can be working on, and let's focus on the things we can be doing, and not just hearing all the things that we shouldn't be. So before we kick things over to Rick, just again, like I mentioned last week, and for those that are new with us this week, just want to make sure you guys know that we at UE Systems and Eruditio as well, we're all here to support you guys in this time. We know a lot of you are working from home, which is different than what you're maybe used to doing, or you're working in a plant that's working harder or working slower. It's just everybody's got different circumstances. So we just want to make sure that even though we might not be able to see you face to face like we're used to doing, or coming in and doing training with you guys, or equipment orientation, things like that, we're trying our best to make the most of technology, and we're here and happy to set up go-to meetings or Zoom meetings, whatever the case may be, and help you guys out as best we can. Maybe this is a great time to get your team spun up on our software or equipment. If you've got questions, if you need any help at all, we want to be here to be your personal ultrasound trainer. Maybe we'll make you do some push-ups as well. I don't know. But anyway, so just keep that in mind and just use us as a resource. Reach out to us. You can get to us from our website, or most of you have my email address, so reach out to me, whatever the case may be, but we want to be here as a resource for you guys. Couple housekeeping notes, and then we'll get officially started. We are recording this, so if you've got to hop off and you can't listen to the whole thing, or you've got a colleague who wasn't able to join us, we'll have this up on YouTube and on our website, and Eruditio will pop it up on their website as well. We'll hope to get that done today. If not, we'll have it up by Monday. We do welcome questions, so you can type those into the questions box. I'll be keeping an eye on those, and I'll get those tossed over to Rick as we go throughout the session, if someone needs clarification on something, or of course at the end we'll have some time for some Q&A. And I said this last week, and it's Groundhog Day around here, so it's the same thing, but just ignore any barking or yelling or arguing. Those sounds are coming from my two kids who are tired of seeing each other constantly, and dogs who are not quite sure why we're around so much. But anyway, I know everybody's kind of dealing with their own thing, and we got to find ways to laugh about it, I suppose. But anyhow, just bear with us. We'll try and keep this as professional as we can. So with that said, I am going to turn the screen over to Rick and let you take it away.
All right. Hey, Maureen, thanks for having me on here today. I hope everybody can hear me okay. I want to piggyback on what Maureen said. I'm actually expecting a delivery from Home Depot. I have people in place to take care of that, but if my doorbell rings, I want to apologize ahead of time. So today I want to talk about something that's very important in the maintenance and reliability journey. So asset criticality is one of the important things that we can do early on after our asset hierarchy is developed, to find out what's important. As you can see by the title, Stop Acting Like a Teenager. If everything critical, nothing is critical. Basically what we're doing today is we're going to compare a factory to a teenager in kind of a little bit of a fun way, and see if your facility is similar to what mine was when I had this revelation. Hopefully it's not, but we're all at different places in our journey with different levels of maturity. So a little bit about me. I'm a U.S. Navy submarine veteran. I was on board USS Baltimore, SSN 704, fast attack submarine back in 1991, or as my daughter likes to say, back in the 1900s, which never stops being funny. I started my industrial maintenance career after one tour there in 1996. And I stayed a maintenance technician for about 15 years at 4 different facilities. after I started to understand more about maintenance and the business side of the maintenance, I decided I was going to learn. I want to be a supervisor. I want to learn more about maintenance best practices. That journey led me into becoming a planner, a scheduler. I spent a little time in an engineering department, maintenance supervisor. I was a CMMS administrator. I ended up starting up a CMMS from the ground floor, which was very exciting. It was very terrifying, but very exciting. I got to do everything from create the asset hierarchies, do the criticality analysis, develop PM procedures. A lot of fun, good stuff. Currently, I serve as a Society for Maintenance and Reliability Professionals Best Practices Chair. And what we do is I have a team of people that work for me as volunteers, and we go over the 70 metrics that we have with SMRP that are the gold standard for metrics on how to calculate certain business factors within maintenance and reliability, things like availability, uptime, downtime, mean time to repair, mean time between failures. And I started out my consulting career as an amateur caddy for my high school daughter golfer, and I can tell you right now that she was not a very good boss, but she will probably say I wasn't a very good client either. She never hit a bad shot. So we're going to talk about asset criticality today, but we're gonna have some learning objectives. So the purpose of criticality analysis is gonna be the first thing I want to talk about. Why are we doing this? It's not just something we're doing to do. It's not something someone should tell us to do. It's something that we need to do. All right, and we're gonna talk about the possible factors that can be used to determine your asset for system criticality. We're gonna learn how to perform the actual analysis itself, and I'll go through a small example of how to go through that process that I use whenever I'm doing asset criticality. There's a bunch of different ways. This is one way, and you can adapt it to however you want to do it. And then lastly, for those of you that have actually done the criticality analysis, this is something that you can benefit from as well. Different things that we can do with that analysis value and certain benefits that we have. Some of them we didn't know when we first got started that we were going to be able to have, but there's going to be some things that you discover too that you can do with this in your facility. So I'll start off by saying that, this presentation and the idea of this started back in the summertime. I was working in a facility and I was having a bad day. Went in there, didn't get much done. We were a very immature facility. I was brought over there to help them get better with maintenance and reliability and do workflow processes, and everything was very old culture, very difficult to change. And I was sitting in my hammock one day just decompressing, of the day, just felt like I'd been spun around, hadn't got nothing done even though I worked really hard. Breathing in the good stuff, breathing out the bad stuff, looking up at the tall pin oak at my feet, and just getting the day over with. And as I was getting out of my hammock, I looked over and my daughter come running up to me at a rate that would be alarming to most people. And she was talking before she stopped. And she's 14 years old, love her to death, lots of drama. And she was explaining to me all the stuff that had happened in her day, all the people that were impacted. And to be honest with you, I was tuning her out because it was just too much for me. A lot of head nodding, a lot of oh wows, and a lot of yes, sure, oh my goodness, and all that was going on coming out of my mouth. I wasn't really listening to what she said, and it snapped back into me. Oh my gosh, I feel like I'm still at work. And then it got me thinking, is it possible that my immature facility that I was sitting in is anything like my teenage daughter? So later on that night, I sat down and I ran the numbers. First thing, as you can see on the left, there's certain habits that I wrote down, and I wondered, were both of them acting the same? And it turns out that they were. So make decisions based on emotion. So, my daughter, she's not capable of making database decisions yet. She's young, she's immature. I don't expect her to, but everything is emotional. My facility at the time was not using data to make any decisions. They didn't have a CMMS at the time. So they were making all their decisions based on emotion. What do you think we should do? Maybe your facility has done some stuff like that in the past. She's very reactive. She's not proactive. We tell her all the time, keep your room clean. That way you don't have to clean it on the weekends. And she fails that all the time. So her breakdown is on a Saturday when she wants to do something, she has to clean her room instead. So trying to get her into that culture, that maturity of saying, look, if you do the small things first, it can pan out in the long run. You don't have to have those long breakdown events on a Saturday when you plan to do other things. In our facility, we were doing PMs. We were having breakdowns all the time. We were probably 80% reactive, and that's being conservative. We were having breakdowns all the time. So that was another similarity I found. React to almost every challenging event with the same level of energy. In my facility, it didn't matter what happened. If it was a big breakdown, every single maintenance tech was expected to drop what they were doing, grab their tools, and run over there. That way, all of our management team could look at operations and say, hey, look, we're doing everything we can. We got all of our resources here. That's not the best way to use your resources. My daughter once lost her iPhone and her hairbrush in the same day, and you couldn't tell the difference outside looking in which one was which, because she was reacting very upset to both events. And obviously one of those wasn't near as important as the other. Incorrect or lack of prioritization of tasks. In my facility, we didn't plan by anything other than trying to stick stuff on the schedule. What could we do? We didn't prioritize anything because we didn't have priorities. They didn't have a CMMS. So in my daughter's case, it's Netflix and chill instead of chores and then Netflix. And so even in this time when she's been asked to not come to school with the rest of her friends, you'd think she'd have a lot more time. The time just seems to slip away when you turn on Netflix. So a very narrow view regarding the impact of their decisions. At this point, she still doesn't understand why she can't go outside and see her friends with the risks we have today. In my facility, it was, we put a process in place, and someone would take that process and then make a small change to it. Now the process is different, not tell anybody, and build those silos up and not communicate the changes of those processes. And what that does in turn is it makes it very difficult to maintain any process control. And within an amount of time, you're going to have 5 or 6 different processes that all go back to the original process. So you got to make sure that your decision making is data based and not based off of emotion. Struggle to set goals and stay focused on the target. Well, one of the things that we would do is we would make a maintenance schedule, and we wouldn't even consult operations about it. And we would hope we got the assets. There were times when maintenance technicians would have to go up and ask people, hey, can I have this machine for 30 minutes to do this PM? We weren't even trying to make a schedule that was even feasible. When my daughter first was part of this stay-at-home or shelter-at-home time, she made a schedule of what she was going to do every single day. I almost took a picture of it and put it on here, but she hasn't done anything on that schedule. She's really good at making schedules. She's not so good at following through. And that's a maturity issue. Can let popular opinion change the way they act. Obviously, this is peer pressure, how kids act, music they listen to, how they talk, and even what they eat sometimes is a habit of a teenager. In our facility at the time, which was very immature and unreliable, what they had was the culture that was always there. We've always done it this way. We don't want to change. We don't want someone new coming in and telling us how to do stuff, because those processes have already been created by somebody else, and you're not going to hurt our feelings. You're not going to make us upset. We're going to keep doing things the way we've been doing. So again, this is a little tongue in cheek, but as you can see, there are some similarities between immaturity. It doesn't matter if it's a teenager or if it's a facility, right? You're going to have those political struggles with your family. You're going to have those political struggles at work. You're going to have those emotional moments. So what are they lacking? They're lacking focus, self-discipline, information, and training. This is all due to immaturity. I don't expect my daughter to know how to drive a car at age 14, but at 18, I think she should know how to drive a car, right? So the biggest thing about this with your facility is going to be your data. If you don't have good data, you don't have any data, if you don't trust the data, you're going to have emotion. It's going to creep in. In the absence of data, there's always going to be emotion, and emotion breeds uncertainty. So the advantage of emotion is that it always leads us astray. All right. So again, those building blocks I talked about earlier, the first thing you can do in a maintenance and reliability journey is understand your assets, understand your hierarchy, get that into your CMMS, list all of your assets, your systems, your components, your replaceable, failable items, get those listed in there. Now you know what you have, and now we need to focus on what's important and how we can maintain that. So first and foremost, the purpose of a criticality analysis, which is the way you're going to get that number, that ranking, is to provide a granular ranking list of systems or assets based upon a combination of factors for the purpose of future decision-making regarding risk mitigation and lowering costs. The whole purpose of criticality analysis is to get that granular list, and we want to do this so we can manage the risk of our assets, okay? Not all assets maintain the same risk. We have to decide which ones have the most. All right, a well thought out criticality analysis factors will produce a method to differentiate systems and assets from each other, even when those are systems or items appear to be very similar. And I have a story to tell later on about how that affected me personally, but there's got to be a difference between asset A and asset B, even if they look exactly the same, okay? There's got to be something that there's different about them, all right? Criticality analysis is not simply an exercise, but a foundational element, like I spoke to before, to any maintenance and reliability program. It should be reviewed at some frequency. You're not going to do this and then put it on a shelf and let it gather dust. This is something that has to be looked at. Every time an asset gets a design change, every time a PM a root cause analysis puts to bed a fault or a failure that's been eating your lunch, you need to revisit the criticality on that asset. And then every couple of years, you need to do a whole system review. You don't have to redo the analysis, but just do a gut check. So where do we begin? First and foremost, you want to attempt to get buy-in from management. And I say attempt because it's not absolutely necessary, because this can be done at a lower level, but explain to your management or ask them, what's the most important stuff we have here? And some facilities have a sort of a criticality analysis where they rank things as high, medium, low, or A, B, C, or 1, 2, 3, however they rank it. And that is definitely a way to say this is the most important equipment we have. The challenge I have for that is that if you don't have an actual value or number applied to that, and it's just a 1, 2, or 3, it's very difficult to get the benefits that I'm going to talk about later, and we'll go into more on that. But ask your management, hey, what's the most important? If they don't know, easy, let me help you. Let me come up with a plan so we can determine what assets are critical. All right, and I'll give you some benefits that you can promote and talk about with them in the future. All right, then we determine where you're measuring the impact of loss or asset or system function. This is one of the most important things. What are the boundaries of your assets? Where does asset number 1 start and where does it finish, and when does it become asset number 2? Also, if you have a system with 4 or 5 assets in a row and they feed each other, you have to determine where your pay point is, where you want to measure the impact. So if asset 1, which is first in the process, and asset 10 is last in the process, but that's the end of the process, you need to really determine the throughput, and you need to determine the factors of asset 1 is how it impacts the entire system as a whole. Don't just look at it as one asset by itself in most cases, unless it's a standalone asset. So that's what we call that pay point, all right? Loss of function should not be measured from each asset individually in most cases. If you have just a standalone asset, it's okay to do it like that. But if it's in a system, you need to look how the asset functions in a system. And most of our assets are in those systems, those assembly lines or milling departments and things like that. Then we develop a list of criteria that will produce a granular ranking. Granular is key. I've said that a couple times so far. I want you to understand that this has to be not a list where every number comes out the same. The numbers have to be different, okay? And this criteria is customizable and will be applied to all assets or systems in the analysis. This is a team activity. When I first did this my first time, it wasn't a team activity and I didn't have all the input I needed. But also understand that this template for one factory may look completely different for another factory because the factors are different, the business needs are different. So there is no one way to say, hey, this is the criticality analysis template for the world. It depends on your business, okay? Then you need to develop a criticality analysis matrix, and we'll go over how to do that in a template to record the answers. You define the system or group of assets to be evaluated first. Typically, this is what's eating your lunch. What do you think the most critical stuff is, and start there, all right? So at this point in time, we've defined what our asset boundaries are. Hopefully they're in your CMMS and you can get that from there. You develop the list of criteria, and you can do this as a group. Develop the matrix and the template you're going to put it into, and then you pick an asset. After that, you get your subject matter experts together, and this should be someone from every department that you can get in the room. So quality needs to be in there. Operations 100% needs to be in there, maybe multiple times. Maintenance needs to be in there, okay? And you got to make sure that these people are the trusted advisors for those departments. The biggest thing we see a lot is we have a new program going on. So the new person who's not a very valuable resource to the actual operation of the facility gets designated as the new help for those new projects and new ideas. Really want to make sure that isn't the case here. This is such an important part of maintenance and reliability, foundational elements, that we want to make sure we get it right. So we got to have people to answer and ask the right questions in the room. Simply schedule a meeting, get everybody together, and begin the analysis by asking the questions on the impact of a factor based upon the criteria. And this will make a little bit more sense when we get to the actual template. You record the values on the template, and once completed, you rank everything by the criticality value. Then you ask everybody for a gut check. And you end up saying things like, hey, what do you think? Do you think this asset is more important than this one? Do you think this is more critical than this one? And if you have a question, you go back and look at the actual analysis, and you can change the factors, the numbers a little bit, but it's not to cook the books to say, oh my goodness, the machine that we think is most critical should be the most critical. You need to check your assumptions at the door when you're doing this analysis. All right, so what are these factors I'm talking about? These are the things and the questions that you tend to ask about in regards to your asset. This is the lens you're going to look at your asset through to say, okay, what factors should I look at my asset? What angles, what departments, what things does this asset provide me? So on the left, I have some mandatory. There should be part of every criticality analysis, and those are operational impact. If this asset goes down, What's the significance of that? What tends to happen? Is it a water fountain where if the water fountain goes down, there's no operational impact, or is it the thing at the end of the process that if it goes down, everything shuts down? There should be a level of difference in that, right? So you have to create those factors. Operational should be the first one. Safety impact. Obviously, you don't want to leave safety off of there, or environmental. How does this impact the environment or safety? Those are very costly failures we don't want to have. Next would be a quality impact. I think quality is a very important factor in a lot of situations. There's some assets that don't really have a quality impact, but many do. So those are your mandatory factors. I think all criticality analysis should have those. And then we have some optional factors on the right. First is maintainability. One, how hard is it to maintain your asset? Does it need ladders? Does it need a boom? Is it a lot of permits and personal protective equipment? Is it special training? How hard is it for the maintenance department to plan and schedule for these jobs and things? So that's one factor that is often used. The next would be accessibility. Does operations need this asset 24/7, 365? Are there different windows of opportunity? Is it like that water fountain where you can fix it anytime you want to, and any maintenance at any time is fine? So those are two really good factors that I like to use a lot. Next would be spare parts availability or lead time. So if your parts are readily available, that makes it easier to get the machine back up and running again. Or is it on the other side of the ocean? It takes 3, 4, 5, 6 months to get here. Okay, so those are things you need to take into consideration as well if you need that granularity. Redundancy or contingency plan. If this pump is being analyzed, if it shuts down and another pump automatically comes back up online, then maybe that system or that pump is less critical than one that doesn't happen. Do you have a contingency plan? One of the things we had in one of my old facilities, we had a pick robot. If that pick robot had an issue, what we would do is we would put people in there in the place of the robot. So we had a contingency plan. It was not an issue that we enjoyed to do, and it would actually change the safety impact on the criticality analysis. But we had a plan in place versus we were just down and no product happened. Another factor could be replacement cost. So if you think about expensive assets, right, they're going to be the ones that are most costly to the business. They're going to be the ones we don't want to waste our money on. So replacement cost can also be something that's very additional to your criticality analysis factors if you need that granularity. So the next three are three that I put on here that some places that I've been, they like to use these three. And I'll caveat this with saying these are three that typically can change over time, right? Asset age can change over time. So if you want to include asset age, that's fine. It doesn't necessarily mean that you're going to have a higher rate of failure. But some people feel that older equipment, they assume it's been less maintained. There's also an argument to say that a lot of the bad things have been worked out of older equipment. So this can be done either on a sliding scale or just a flat number. But I tend to shy away from them, but I put it in here simply because the age factor is something a lot of people like to use. Just understand that it is temporary. It could change just like the next two. So repair time or mean time to repair. If you have a long mean time to repair, a lot of times what ends up happening is an analysis gets done on that, and we try to figure out whether it's a SMED activity or what to get those steps down to what do we actually need to do to get this done. So again, if you put in a value for a mean time to repair and then later on someone comes along and does a root cause analysis, it makes your analysis irrelevant at that time because that factor is no longer true. And the same thing with mean time between failures. If you have a very short time between mean time between failures and your machine's not very reliable, we have programs in place at a lot of facilities, even immature ones that are doing design issues and things like that. So I put those last three on there to say, yes, those are factors you could use. I would say that to use those with a bit of caution and understand that if you do include those, that you will have to look at your criticality analysis a little bit more than you would if you didn't use those. All right, so let's look at a template that I was talking about. And as you see here, it's just a simple Excel template I put in here. This is a relatively small one. I wouldn't, if I was doing an asset criticality analysis for a facility, I would use much bigger. This is a 5 by 6 or 7 or so. Typically, you can do a 10 by 10 or an 8 by 8, depending on your level of granularity and the number of assets that you need. But as you see across the top, you've got the category, then you've got the different, the 4 levels of significance. You got the categories down the left-hand side there and the weight. I'll talk about the weighting in a second, but you see how it fills out here. So a safety consequence of 4 is if this asset had a failure, it could result in personnel death. So obviously that's the most important thing. All the way down to the accessibility consequences. On the negligible side, which are no accessibility restrictions, system is accessible 24/7, 365. That's probably that water fountain we're talking about. And there's different ones, and you can set this up however you want to. Operational and manufacturing consequences, a failure could lose 100% capacity, 75% capacity, 50% capacity, and obviously, if you're doing this with more factors off to the, with more numbers and values off to the right, more columns, you want to definitely pick some more than 25, 50, and 75 in there to give you some granularity. And it's simple. When you sit down to do your analysis, you take an asset number 1, you say, okay, if this thing shuts down, what's the safety consequence? And everyone in the room just sits down and says, well, there's no failure impact, no safety impact to this. And they give it a 0. You put that in your template. You go to the next one, environmental consequence. Well, it's a localized spill, but we'll take care of it. Okay, that's a 1. You put that in your template, all right? So off to the side, the weighting. Some factors or categories are more important than others. I can't sit here with a straight face and tell you that maintainability is just important as safety for your assets. Some people don't use weighting. I like to use weighting because it gives that value of, yes, safety is the most important. Some people put a 5 down for environmental as well. I just put a 4 in there to show the different weighting on this one. And this has to be maintained. So actually a value of 4 in safety consequences, the catastrophic would actually be a value of 20 going into your system versus a 4 under maintainability would be an actual 4. All right. So again, this is just used as for the facilitator and all the people to understand when you're asking the questions about the asset, where does the asset fall into this matrix? All right, and each one of these values can be different. So I've got an example template up here, and off to the left, I've got the assets listed 1 through 20. This is where your assets or systems would be numbered. Across the top, you've got your weighted value, and then you have underneath the safety, environmental, manufacturing, et cetera, across the top in the yellow, you have the values that the facilitator would enter in once the analysis was done for that particular factor on that asset. It's a simple Excel calculation. It's easily Googleable, and you can figure out how to do it. It's on it creates the criticality score on the right. So as you can see, asset number 1, we did the analysis on that one, and it came out as an 18. Asset number 2 at 50, asset number 3, 70, and such and such. So you see, after you fill this out, and again, it was just 20 assets that we did the analysis on, and you can do this by system, you can do it by area in your facility, or you can do it holistically, the entire facility. So after this, you got to rank it. So you basically sort by your criticality score, and it comes out that asset number 3 was the highest, number 17 was the next, and then you had 2 at number 50. But I want you to look even more so at the results. We have some duplicates there. There's 2 50s, there's a couple 38s, a couple 36s, but for the most part, there's that granularity. This tells me that our asset criticality factors in our analysis was effective. If you see a bunch of 45s and a bunch of 70s or whatever, then you say, you know what, we didn't have the right factors. And you can kind of tell when you're doing your analysis as you're going along, these numbers they're starting to really stack up here. We need to go back and look, and then you have to kind of start over. Not fun, but it's necessary to make sure you get that granular results. So typically what we do is we have we want to determine what the most critical value is, right? So your critical assets get maintained a little bit differently. Typically that's done with the 80-20 rule. So your top 20% in this would have been the top 4, that 70, 60, and those 2 at 50. But this is not a hard and fast rule. It may be different depending on the size of your maintenance group. So if you have a lot of resources, maybe you can go 25. If you don't feel comfortable saying, I'm going to maintain these critical assets, if you have 2,000 assets, that's a lot of assets. So if you want to maintain, or say we're going to do the top 10% or 5% just to get started, and really going to nail down what we need to do on that, and maybe expand it later when you get more time and farther down your journey. It doesn't mean that the bottom 80% are not maintained and even ignored. There are run to failure opportunities there. It just means that you don't maintain them at the same level as your critical assets. It doesn't make sense because they're not that important to the business. All right, so now you have this asset criticality analysis done, and it's great. First thing, what do you do? Well, I would say put it in your CMMS. In your hierarchy, you've got that asset registry, you've got part numbers, you've got purchase dates, you've got all that stuff. Find a field. Many of them have that criticality field that you can put this number into. If you don't, hijack a field. Talk to your admins. Say, hey, can we get a field that we can use for criticality, and put that number in there. It'll be beneficial later on. Now, the criticality itself should be a document that's saved somewhere, but get that value into that asset registry. Very important to help you along the way. But we found there's many things that you can do with asset criticality. All right. So the first thing is asset strategy development. All right. These are the things we want to make sure we're doing a failure modes effects analysis on, or RCM activity. All right, we want to find out the risk of these assets actually failing. We did it at a high level with the criticality analysis. We're going to take it another level deeper to find out the component failures that could possibly happen. All right, we're going to develop maintenance strategies that mitigate the failure modes of those critical assets. So we're going to get that analysis. We're going to find out what we're doing. Sometimes it's a redesign, sometimes it's run the failure. All right, but this is also an opportunity where condition-based monitoring programs come in. These sometimes can be expensive programs to start up, but this is where we can say this is where our bang for our buck actually happens. We're working on our most critical stuff first. If it's rotating, we're going to do some sort of listening to it, whether it's vibration or ultrasound. All right. Not only that, once we find these failures that we're going to try to get more time to plan and schedule for, we're going to develop precision maintenance procedures. So when that bearing goes out, we're not just going to say, all right, we've got 6 months because we have an early warning now because we're doing structure-borne ultrasonic testing on it. We're going to create a procedure that is going to tell our technicians exactly how to put that bearing in the perfect way, pre-lubricate it, preload it, and get it in the right way so we don't have that same failure again. But again, that might not be something you want to waste your time doing on the water fountain. I keep using that example, but we have many water fountains in our facilities, or assets that are similar to that. Resource allocation, and this is something that came up in our area we weren't expecting. We found out that most of our critical equipment was in one area of the plant, but yet we were continuing to hire staff in another area where impacts of failure were low. They were very reactive and they wanted to make sure they got their reaction times down, but we found out, hey, you know what? We can have longer reaction times in that area. We don't need that level of staff. So you can allocate appropriate staffing levels to critical systems while justifying lower staffing levels on non-critical systems. We were able to move 10 maintenance technicians out of a group of 20 out of one area and put it someplace that was critical and start doing more PMs on those critical assets because the other area didn't have any critical assets in relationship to the plant. You can identify the need for more support or justify the current staffing levels that you have. So that's another way you can benefit from that number. And that's why you need a number to say this area has more than this area does. If you do the ABC thing, you know, it's very hard to quantify that. Another benefit is improvement projects. So capital project justification should be simpler on critical assets. And also it's a way to identify areas where you can do pilot programs. Let's say you want to start up an operator care program or a PM optimization effort. Why start that on a non-critical assets? Let's start with the critical assets so we can get the biggest bang for our buck and put failures to bed that we're having on critical assets instead of something that, you know, even if it is eating our lunch, it's not as critical as the other areas. Spare parts and inventory is another factor that can benefit from criticality analysis. You identify when spare parts may be needed or be stored in-house due to high asset criticality. Keeping spare parts in-house is extremely expensive, right? You don't want to pay depreciation and tax on things unless you absolutely have to. So when you have a critical asset and you've got those spares, those motors, those hard to find things, you're going to want to keep those in-house, and it's easy to justify. Why is that on our shelf? We haven't used it in 3 years. Well, we have to have it. It takes a long time to get here. It's a critical asset. Those sorts of things. Not only that, you can justify the elimination of lower criticality assets, spare parts from the storeroom, or at least lower their levels. Do you need 500 filters? Probably not, right? So you can use criticality analysis to determine what you need and what you don't need. This is the biggest one that was a surprise to me. And so if you take this journey in the order that's supposed to happen, you get your registry right, you find out what's critical, you do your FMEAs, you're going to have these failure modes that are common across different asset classes. You're going to have rotating equipment, you're going to have bearing failures that happen a certain way. You may find out, hey, you know what, we're having a lot of lubrication failures. When you get that data based on the criticality of the asset, you can say, okay, my critical failures on my critical assets are always these 5 failures. And you can put training programs together to, one, identify those failures when they happen, right? Or train on the recovery of those. So back to the vibration thing, we went out and we bought a vibration analyzer and put it on a bearing. And so we had to get training for that. And then we had to come up with a precision maintenance to replace that bearing so the failure didn't happen again. These are things that we trained on that we weren't training on before. based on the failures that could happen, the risk that was happening in our facility. All right, this was a big win for us. We had prescriptive training at that point. The other side of this is to reduce or eliminate training on non-critical processes, okay? And this was something that was kind of slow to take hold of, but once we started doing the training on the good stuff and getting everybody skilled up, we started to realize that we didn't have a need for the other stuff as much. And it was kind of like we did that whenever we could. It wasn't an important, stressful training. We didn't mandate that all of our technicians went through that training as much as we did the others. So training is another thing that can be used with asset criticality. Maintenance cost verification, this goes back to capital again. But you should also maintenance spending on non-critical assets should be heavily scrutinized. All right. If you're spending a lot of money on something that's not critical, you may need to do a root cause analysis and ask yourself why. Why is it that we're spending all this money? In turn, justification for spending on critical assets is much easier, although you still want to scrutinize it, but it should make more sense. We should be spending more money maintaining our critical assets than we do our non-critical assets on an asset-to-asset basis. So this is the last one we'll talk about today, but it is probably the biggest win we had. The reason we put a value and not just A, B, C, 1, 2, 3, reason why we go through that process is so that we can plan and schedule work with lack of emotion, with more database decision making. There's a formula out there called Ranked Index for Maintenance Expenditures, RIME Index. And it takes the criticality asset times the priority that's on the work order, and every night at midnight it bumps it up by that value up by 1. So now we have a ranking of our work orders that takes into consideration the effect of not doing the work in the priority, and also the impact to the business based on the asset. So we manage the risk from a couple of different angles there. So the backlog then gets ranked by whatever work order gets put in today versus last year, where they all hash out. That's easy for the planners to then say, okay, what do I need to plan now? And once that plan work is done, the scheduler can say, okay, what's the ranking for the plan work? And this is what I need to put on the schedule. When I was a scheduler, I would start off my week for the next schedule simply by saying, okay, I've got 100 craft hours. I would start at the top after I ranked that list, and I would go down until I reached 100 hours of work. And I'd say, okay, this is what we should do. Unless we have some constraints that I'm not aware of, right? What can we do? All right. It made it very easy for me when I was in my meetings to say, this is what we're going to do. Does anybody have anything that needs to bump up there? And let everyone know where their work order ranked. You have to make sure people aren't gaming the system, obviously, but that's part of the job of the planner. But it made it very easy to justify what work got done. Not only that, it let me know what the most important thing was to put on the schedule. And I felt like I was mitigating the most risk every week because of that value that got put into the asset hierarchy. All right, so I'm gonna tell a little story about when I first got started and some of the pitfalls that I made, because some of you that have done this or are looking to do this, it's a big deal. It's hard to get started. And when I started off, like I said, I was a maintenance technician. I'd be working on one piece of equipment, and my boss would tell me to stop working on that and go work on another. And I thought, this isn't the way to live. There's got to be a better way. So I tried to come up with this analysis, and I did some research, and I found out this thing called asset criticality. So I developed my own matrix, and the facility that I was in had a bunch of different departments. And I went to my department that I was familiar. I've been working there about 10 or 12 years. I knew the equipment, and I started doing the criticality analysis by myself. And we came out with this granular ranking, and it was pretty good. Everyone loved it. We started scheduling by it and everything, and sure enough, word got out, and I was told by the department head to go to another department and start doing maintenance or asset criticality in their department. So I set up a meeting with the maintenance manager, and I went down there and I told him what was going on, what I was there for, and he said, yeah, I heard all about it. It's not going to work here. And I asked him why not. He said, well, I've got a linear process. If one thing shuts down, everything shuts down. It's just one thing feeds another. I've got a work in progress. It's just one big long assembly line. I just don't see how you're going to get anything out of it. It's all going to be the same critical. Everything here is critical. And so I left, told him thank you, went back home, went back to my desk, sat there, ended up going home still with no answers. And I was laying in bed that night and it hit me. If everything's critical, then nothing's critical. He is reacting to every failure with the same amount of energy, right? He is very much just like a teenager. Everything is critical. They react to everything the same way. That's all they know. Throw more energy at it, right? So I got to thinking, and it all comes down to those factors. I told you this story just to let you know, it all comes down to those factors. There's got to be something in those criticality factors that you can determine. He was only looking at the operational impact. All right. So we had to go through and do some spares stuff. We had to do some redundancy stuff. He did have some redundancy, and we found enough factors. We were able to give him what he needed. And in the end, it was a good product. And I learned a lot from it. First and foremost, don't do it by yourself. So if you're doing this by yourself, get a team of people. All right. Understanding which assets are critical and which assets are not is a key foundational component of any maintenance and reliability program that decides to begin a journey towards best practices. Without this information, proactive data-based decisions regarding asset care will be very difficult or even impossible to make and defend. So at the end of the day, it's all about having data. And if you don't have asset criticality data, it's very difficult to say, what do I do? Where do I go? Where do I concentrate my energy? Again, that emotion creeps in without that data. And emotion is uncertainty, instability. We don't want that in our process. All right. For those of you that are just starting out and haven't done this at all, you're going to run into some roadblocks. All right. And the conversation you have is, are you happy with the system you got? Are you happy with the results you're getting? And I always say, in order to get better results, you have to be doing something you've never done before. So you have to make sure you tell people, look, we can't do the same thing and expect different results. We have to do things differently. And it all starts with those foundational elements, the hierarchy, right? The asset criticality, the FMEAs, good PMs, planning and scheduling, like we learned about last time with Sean Eisenhower. We have to get these things done, okay? All right, so here at Eruditio, we have a complimentary no-cost program for training and development with our friends in the industry, and we're supporting that provides training videos, project support, coaching, e-learning templates, resources, maintenance reliability practitioners at your service, because we're going to be working from home. We have a little bit more bandwidth, but this is going to be something we're trying to do to help you guys come out on the other side of this with maybe some wins that you can have. Maybe you need help getting your asset criticality template developed. Give us, sign up. Help.eruditio.com is where you can go to get that help. Again, it's no cost, complimentary. We'll have a coach get in touch with you, and we'll help walk you through this project-based charter that you're going to be working on this project, so you come out of this with a win. All right. With that, Maureen, I'm done. If anyone has any questions.
Yeah, awesome. That was great. Really good information, and appreciate you taking the time. And I think it was a perfect comparison there at the beginning. So that was clever, and I think it probably hit home for a lot of folks. Okay, so some of the questions that rolled in. Let's see here. Well, someone wanted the example of your matrix, which you did pop that up there. So certainly, if you guys want actual physical copies of any of this, I'm not sure what Rick and Eruditio are able to share out, but Rick's contact info is there, so that's your best bet. So someone was wondering, as far as when you're talking about your criticality, what about the cost of lost production? How does that factor in, or does it?
That's that operational impact. So you can do that many different ways, and that's an excellent question, because typically what people see is the numbers of product. But if you have the ability to track your production cost loss, that's another way. You don't even have to look at your numbers to make it. So for example, if you know that it's going to cost you $1,000 an hour to be down, and this breakdown typically takes 5 hours, then that's a $5,000 breakdown. That's a great way to figure it out. How long is the breakdown of this asset typically down for? That's a great way to look at it.
Okay, cool. And another question, for those that are working at home and kind of doing that here for the foreseeable future, is this something that you think folks could start to tackle, even if they're not in the plant? And any suggestions for how that, if that is something you think they could do, any ideas of ways that they might accomplish that?
So for those working at home, if I'm understanding, what can they do? Is that what I'm understanding the question to be?
Yeah. Yep.
Okay. So typically, it's hard to get access to the teams. It's hard to get access to the machines. What I would think is start thinking about those factors. Start thinking about what's important to your business. What are some of the things that we deem important? Do we have spare parts issues? Do we have maintainability issues in our facility? And start creating that matrix. you can have a matrix developed and bring it in front of a team, and then we can discuss it. That's fine. The other thing is start thinking about how you're going to frame that conversation with your facility, and also from the benefits that you've seen today. I think there were 6 or 7 that I promoted on here. Which ones do you think are going to be the most impactful to you? What problem do you want to solve with asset criticality? Think about how you can get it into your CMMS. Do you already have a field? Think about the fields you've seen in your asset registry if you've already seen that. Is this a conversation you're going to have with your admins with your CMMS? So those are some of the things that you can do now. And you know, there's probably more, but those are some easy wins.
All right, wow, the questions are really flying in. So I'll just give a quick caveat that if we don't get to everybody's questions, the system does allow me to generate a report, and I will ship the questions over that we didn't get to Rick, so he can be in touch. And just to clarify, someone pointed out there is a slight typo. So if you're taking Rick's email address down, just take that N off the end of Eruditio, and then you've got it. So Clonan at eruditio.com. That's okay. That's okay. The teenager was probably bugging you when you were putting this PowerPoint together. Okay.
100%. She actually made the presentation.
Oh, she did it. Okay. Perfect.
Yeah.
All right. So here's a good one. If I'm working with multiple sites that make the same thing, is it safe/okay to call the same equipment critical across them all? Or should it be plant by plant due to some of the other factors that you discussed?
So this is a really good question. So if you have multiple plants that are identical, I would say that you probably could leverage one analysis across several plants. If you have one system that's similar, same thing. However, if there are any differences at all, any business needs, any quality concerns, if the environment is different, for example, one plant is 72 degrees air conditioned and fine, and the other one is open air, but it has the same machine in it, I would still do the analysis on the other side. The numbers may come out being the exact same. It depends on those factors. But I do think that that is an excellent question. I've not been asked that one before, but that's excellent.
Yep. Okay. So let's see here. My goodness, this is really, you've hit some nerves here with this presentation. Got a lot of questions coming in. Okay, so hold on, sorry, then they're getting off my screen as more come in. So about how long did the process take for you? So folks are kind of looking for kind of a timeline of what they can expect to start to finish, kind of get this thing up and running.
Right. Yeah. So, and it was funny because everyone, and you know, new processes, maintenance reliability, everyone thinks this is going to take forever. In all honesty, if you have a 10 by 10 template, how long does it take you to ask 10 questions? How long does it take you to get 10 answers with 10 people? When you first start out, absolutely, there's going to be just gnashing of teeth and arguing and realizing that, you know, oh my gosh, you're not going to put that this low because I feel it's this high, especially if it's their factor. They're talking about operation, people talking about the operational factor. But as you go through it, people start to hit a groove, and you can get, oh my gosh, we went from hour-long meetings where we would get 5 and 6 done to within 2 weeks we would schedule 30-minute and we were 30-minute meetings, and we get 20 to 30 done. So it's one of those things that feeds itself. I'd actually considered at some point actually just sending out an email and having people discuss what they thought. I pulled back on that because you need to have that interaction from people. But that 30 minutes, we would get 15 to 20, sometimes 30 of them done. And complexity is an issue sometimes, but for the most part, people understand what's expected of them when they come to that meeting, and it can get going a lot faster. So it gets faster than you think.
All right, you've got another fellow Baltimore sub guy on here saying hello, so that was interesting.
Reach out to me.
Yeah, just at the correct email address. Sorry about that. Have to poke a little jab there. Okay, so how do you keep consistency on the ranking if you have multiple people working on the same spreadsheet?
You have one facilitator that records the number in the spreadsheet. So one person, usually it's your reliability champion, reliability engineer, sometimes it's a maintenance engineer, that's the facilitator. And you don't put a number in until there's a consensus. And that's how you keep that. If that answers the question, I think. That's the job of the facilitator.
Okay. And let's do one more, and then we've got a couple things we want to get to. And like I said, if we didn't get to your questions, just, we'll be sure Rick gets a hold of these. So again, kind of talking about sort of this team, do you have a suggested number of folks that should be a part of it? Can you possibly have too many cooks in the kitchen? What's sort of a good sweet spot for involving the right number of folks to get the right number of opinions, but not too many?
So let's take a 10 by 10, right? Or an 8 by 10, meaning 8 factors and 8 things, 8 columns and 8 rows. I would have to say at least one person from each that's impacted on the left-hand side. So if you've got operations, you need at least one operations person, but it needs to be someone that's relevant to the operation that you're actually analyzing. So that person can change in and change out. Secondly, you need someone from maintenance. Sometimes it can be the facilitator, but we would provide it not be the facilitator. Someone from maintenance, someone from quality. Sometimes you can have someone from the storeroom. Depending on what those factors are, at least one person needs to be there for each one of those. And a couple of them can be the same person. The same person can be there for maintainability, that can be there for spare parts availability, or whatever those factors are. I'm just giving examples out here, but make sure that there's at least one person there that can answer the questions on that. Sometimes there's more than one because there's overlap, and that's even great. There's discussion, but it lets people understand from a different perspective. Sometimes operations answers the question, and it's actually a maintenance question. And the maintenance guy, we've had this happen before. Maintenance guy goes, you know what, you're actually right. So it helps build those bridges.
Awesome. All right. Well, I'm going to take the screen back here, and while I do that, just wanted to point out again, for those who maybe joined just a little late, we are recording this. So if you jumped on a little late, or if you have colleagues that you definitely want to hear this, we'll have this up on YouTube and on our website, and Eruditio will have it up on theirs, either today or, by Monday. So definitely take advantage of checking this out again, when you're done, streaming Tiger King. And so that'll be available for you. And just to kind of close up, we want to give a little heads up about the webinars that we've got coming up. We're probably going to be adding to this, but for now, this is what's on the agenda. Next week, we're going to do 2 on Thursday. We're going to have Jeff Hay with RDI Technologies on to talk about motion amplification. Oh my, should have had a little sip of water before I did that one. But Jeff is actually on and was going to just give a quick little overview so you guys know what you can expect to hear as we move into next week. So Jeff, if you want to pop on and give a quick little summary of what we can expect for Thursday's webinar.
Yeah, thanks, Maureen. Yeah, so I was just going to talk a little bit, kind of give an overview of the technology, what it is, for those who are unfamiliar with it, and then go through how it's implemented in a reliability program, how it sort of fits in a toolbox of other tools, and how people utilize it as a complementary tool, and then also go through some very specific use cases and some case studies, how some end users have implemented it, show the things they're using with it, and how they're solving problems with it.
Awesome. Okay, so we'll look forward to that, and we'll certainly be getting we'll get an invite out for that, probably on Monday, so take a look for that. Then on Friday, we're gonna kind of toot our own horns a little bit and talk about ultrasound. So, part of what Sean Eisenhower and the folks at Eruditio came up with at sort of the start of this was how we can be productive and proactive during this time, and what are our project plans we can put in place, and what are the different tools and things that we can either start preparing that we're going to implement once things get back to normal, or even start implementing now. So, of course, learning about what Jeff's got, and we're happy to share all the things that ultrasound can do to help you in your facility. So that's what Friday will be with Adrian Messer. And then the following week, we'll dive into job mapping and creating job plans with James over at Eruditio as well. So that'll be a great session. So just be on the lookout for those invites. Again, at this time, we're just trying to kind of be together as much as we can while being apart, sharing information. We're having great turnouts on these, so people are obviously looking for looking for this kind of information and looking for, I guess, just a break in the monotony of these Groundhog Days that we're living in. But anyhow, so we're hoping that some of these topics are something of interest to you guys. So check out the invite for that. And I'll just remind again, we're all here, the folks at Eruditio, Jeff at RDI, ourselves, we're here to be a resource and be a support for you guys during this time. So don't hesitate to reach out. Happy to do one-on-one software trainings or just conversations. If you just feel like talking to somebody other than your kids, just holler at us and we'll be in touch. But want to thank Rick again for a great session. Thank you all for joining us. Everybody stay healthy, and we will catch you guys later.